Hello, welcome everybody. Here is your lesson on 10-4, Inscribed Angles. There's not too much on your note sheet. It's just the inscribed angle theorem that says through examples here the measure of angle CAB is half the measure of arc BC, and that the measure of BC is 2 times the measure of CAB. So let me explain what that really means through these pictures I enlarged here. What it really means is that if I have this angle inside of a circle, and inscribed means kind of like the edges touch the circle, then this blue arc right here, if this is 40 degrees, and 40 degrees would be the degree measure from the central angle, 40. But what happens if it's not from the central angle? What happens if it goes all the way to the other side of the circle, but still touches in the same spot? Well, then it's not exactly 40 to 40, it's like half of that, so this would have to be 20. So here's another example using this circle, and once again, this part of the circle, this angle inside, touches a side way over here. So instead of going half, I'm going to double this one. So if this is 15-degree angle right there, then this arc is going to be double it. It's going to be 30. Please do not confuse this with a central angle. If I connect these same spots here to here, if this arc is 30, the central angle is 30. But if I go all the way to the other side here, then it becomes half, or the arc is double. So an inscribed triangle with a diameter of an edge must be A. In this case, I'll just kind of explain this through a picture. So let's use a different color here. So here is my inscribed angle right there, and if it touches a diameter, my diameter is in blue here because it goes through the center of the circle, then what do I know? I know that this arc around here on this outside is 180 degrees. Why do I know that? Because it's half of a circle, which is 360. So by the theorem that we previously used, this has to be a right angle, or 90 degrees, because it's got to be half of that arc. All 3 of these angles must total 180 because it's a triangle, but I know for sure that one right there is got to be a 90-degree angle, a right angle. On this problem here, it's an inscribed quadrilateral. Now, a quadrilateral is a 4-sided figure. So in this case, if I have an inscribed quadrilateral, inscribed meaning the corners touch the circle, then the opposite angles are supplementary. So if I'm making up some measurements here, let's say this is 50 degrees right there, that angle right there, then this one here, supplementary, has to total 180, so this has to be 130. And you're going to use that to solve problems. Okay, and likewise, if I knew that this guy was, I don't know, 50, then this guy here would have to be 130. Or I'm going to use the same numbers, so let me pick different numbers. If this guy is 80, then this guy here has to be 100, because 100 plus 180 is 80 plus 100 is 180, which is supplementary. So that's how you're going to solve problems like this. Here's example 1. Find xy and the measure of arc DCB. So if A is 58 degrees, so right here, that's 58 degrees. And B is 2y plus 16 right there. And C is 2x. I'll do double arcs for that one. So this is a single arc, and this is a double arc. I know that these two, because they're opposite angles, they must be supplementary. So A and C have to total 180. So A is 58, C is 2x, so I got 2x plus 58 equals 180, and then I would just end up solving that equation. Grabbing my calculator here, I'd go 180 minus 58, and I get 122, and that equals 2x, and then I divide by 2, I get 61. So x equals 61. So that would be x. And then if I was going to find y, I never did d. D would be like the double arc here. These two have to total 180 also. So I'm running out of room, so I'll kind of go up here. So 2y, that's b, plus 16, plus d, which is 3y plus 4, equals 180. So 2y and 3y is 5y. 16 and 4 is 20. That equals 180. And then I subtract 20, I get 160 equals 5y. And then 160 divided by 5 gives me 32. Y equals 32. And then if I wanted to measure of arc DCB, I'm going to do this in black, D to C to B, I noticed that through that other theorem I talked about in the other class, this is my inscribed angle, so if I got that angle, then this arc would be double that angle. So I need to find A. A is 58. So if I take 58 times 2, I get 116. This would be 116. All right, a couple more quick ones. If I want arc GH here, this is GH. I know that this is a diameter right there, so I know that that's 180. If I could figure out this, then I could subtract from 180 to get that. Well, this is my inscribed angle. That's 20, so this has to be 40. So if that's 40, I go 180, the diameter minus 40, I get 140 degrees for arc GH. All right, this one is always a weird one. It's like a bow tie problem. You can look in your book for an example like this or look on your note sheet. But it's pretty simple. It's pretty straightforward. It happens to deal with, I'll just kind of explain why it works, and then we'll just learn how to solve it. If I look at this black angle and this red angle, I notice they touch the same arc. So if they touch the same arc, if this was 40, both of these angles would have to be 20. So that's an example with numbers, but I don't know it's 40. But I do know these are the same because they touch the same location. So I could just do 5x equals 7x minus 8 and solve. I'm not going to solve this because this is just a quick explanation. You can all do that. And then once you get x, you can substitute back in there and get the measure of that angle. Then if I wanted to do going the other way of the bow tie, going this way, these two touch the same spots as these two, so I know these two angles are equal. Likewise, I could go 4y plus 7 equals 5y minus 3 and solve. All right, last one, example 4. Finding x. All right, well, this goes through the diameter, so I know this has to be a right angle from that last slide. I also know it has to be a right angle because this has to be 180. That's an inscribed angle. It has to be a half of that. So I know that all three angles, angle 1 plus angle 2 plus angle 3, must be equal to 180 in a triangle. And I know one of them is 90. That's angle D right there. That's 90. So I'm just going to take away 90 from both sides, and I get 90 equals these two guys added up. Well, what are those two guys? 3x plus 5x minus 12. And then you would just solve. 8x minus 12 equals 90. You add 12 to both sides. 102 equals 8x. And then you take 102 divided by 8, and you'd get 12.75. It is a decimal, but you get the picture. I hope this was helpful. Thanks for listening. Have a good day.